Hello everyone, I'm Johnson, Department of Chemistry. So today class we are going to talk about atomic structure, chapter 4. Last class we discussed about arrangement of electrons in the atom and then electronic configuration and then isotopes. First, what is mean by isotopes? Atoms of the same element having same atomic number but different mass number are called isotopes. Okay. What is the arrangement of electrons in the atom? What is the electronic configuration? The arrangement of electrons in the various shells or energy levels of an atom of the element is known as electronic configuration of the element. Okay. So, in other words, we have to tell that electronic configuration is the distribution of electrons in various cells, okay, or we call as energy levels of an atom, such as K shell, L shell, M shell, etc. So the nearest orbit from nucleus is labeled as K shell. Next to that is L shell, then M shell. Okay. So and then we have to discuss about both the scheme. So this scheme tell about the maximum number of electrons that can be accommodated in any energy levels of an atom is given by the formula 2n square. So what is by n? N represents the number of that shell. So that we have to apply the K shell is n is equal to 1. So the number of electrons 2 into 1 square is equal to 2 electrons. Okay. And then L shell is n is equal to 2. So the number of electrons is equal to 2 into 2 square is equal to 8. Like that, N shell having 18 electrons and then N shell having 32 electrons. Okay. So and then we have to discuss about that the outermost shell of an atom cannot accommodate more than 8 electrons. Okay. So even if it has a capacity to accommodate more electrons, however, the outermost shell of an atom is the first shell or K shell, then it cannot accommodate more than 2 electrons. Okay. So today class we are going to talk about valence electrons. Okay. What is meant by valence electrons? The outermost electron shell of an atom is known as valence shell. Okay. The outermost electron shell of an atom is known as valence shell. That means the electrons present in the outermost shell. Okay, the electron present in the outermost shell of an atom are known as valence electrons. So this shell is a valence shell. These electrons we call as a valence electrons in the outermost shell. Or we have to tell about this is a valency electrons. Valence electrons or valence electrons. Because they decide the valency of the atom. Because they decide valency of the atom. See this example for carbon. Carbon atomic number 6. So then 2 electrons filled in a K shell and then another 4 will be in a L shell. Okay. So it is a combining capacity because they decide the valency of the atom. That means decide the combining capacity of the atom. Okay. And then only the valence electrons of an atom take part in chemical reactions. Keep it in mind, student. So only here, only one valence electron, for example, is a sodium atom. So these valence electrons of an atom take part in chemical reaction because they have more energy than all the inner electrons of the atom. Okay, like K shell here, K, L, and then M. So this M shell having more energy than all the inner electrons of the atom. Okay, this M shell only take part in chemical reaction. So let us take the example of sodium atom C to understand the meaning of valence electron theory. Okay, so the atomic number of sodium is 11. Okay, atomic number of sodium is 11, which means that one sodium atom has 11 electrons in it. Okay. Okay. See the electronic configuration of sodium atom 2, 8, 1 because in 2 shell 2 electrons are filled and then L shell 8 electrons are filled, and then outermost shell only 1 electron will be filled. This is we call as valence electron. Okay. So this is electronic configuration 2 8, 1. In the sodium atom, M shell is the outermost shell or valence shell. That you have to know. So there is only 1 electron in the outermost shell of sodium atom. Therefore, sodium atom has 1 valence electron. Here, chlorine. Chlorine having 1, 2, 3, 4, 5, 6, 7 valence electron. Okay. Okay. See, when a sodium atom combines with other atoms, only its 1 valence electron in the M shell take part in chemical reaction. Okay. Only this one shell, 1 valence electron take part in chemical reaction. So the electrons of 2 inner shells, this red color and this blue color, the electrons of 2 inner shells of the sodium atom never take part in chemical reaction. Okay. Because this M shell only having more energy. Because the outermost shell only take part in chemical reaction. This K shell and N shell of the sodium atom never take part in chemical reaction. So we can now say that those electrons of an atom which take part in chemical reaction are called valence electrons. Okay. Electrons of an atom which take part in chemical reactions are called valence electrons. So in order to find out the number of valence electrons in an atom of the element, so we should write down the electronic configuration of the element by using its atomic number. Okay. So if carbon 6 means 18 is the atomic number, so the electrons also same 18 electrons. So the outermost shell will be the valence shell, and the number of electrons present in it will give us the number of valence electrons. Okay. So see the example here. So what is the number of valence electrons in the atom of an element X having atomic number 17? So name the valence shell of this atom. That is chlorine. Okay, this is a chlorine. Atomic number 17 as a chlorine. So in order to find out the number of valence electrons, we should write out the electronic configuration of element X. Okay. So the atomic number of element X is 17. Is 17. So one atom of X contains 17 electrons. Okay. So one atom of X contains 17 electrons. See here 1, 2. Here 8. 8 plus 2, 10. 10 plus 7, 17 electrons. So the electronic configuration will be 2, 8, 7. KLM. Okay. 2, 8, 7. So here M shell is the outermost shell or valence shell of the atom, and it has 7 electrons in it. See here. So this chlorine having 17 electrons. That means 17 protons. Okay. The proton also same. Proton is equal to electrons. Okay, number of electrons, and also atomic number also same. Okay, see here 1, 2, 3, 4, 5, 6, 7, 8, 8, and then here 1, 2, 3, 4, 5, 6, 7. 7 is an outermost shell. Okay, so there are 7 valence electrons in the atom of the element. Now, inert gases. What is the inert gases? The atoms having 8 electrons or acted of electrons in their outermost shell are very stable and hence chemically unreactive. The atoms having 8 electrons in their outermost noble gases or inert gases having outermost shell 8. Okay. So they are having 8 electrons in the outermost shell. So it is very stable. Okay, so the atoms having 8 electrons in their outermost shell. That 8 electrons means we also tell about that is octet of electrons. It is very stable and hence chemically unreactive. Okay, so elements like helium, neon, argon, krypton, xenon, and radon are known as noble gases or inert gases because they do not react with other elements to form compounds. Okay. So elements like helium, neon, argon, krypton, xenon, radon are known as noble gases or inert gases because they do not react with other elements to form compounds. So except helium, helium having only two valence electrons. All other noble gases have 8 valence electrons. See, neon also having 8 valence electrons, and then argon having 8 valence electrons, krypton having 8 valence electrons. So noble gases have full valence shells with 8 electrons. Okay, so all the noble gases with outermost shells. So since atoms of noble gases are very stable and have 8 electrons in the outermost shells, except helium. Okay, therefore to have 8 electrons, the outermost shell of an atom is considered to 8 electrons in the outermost shell of an atom is known as octet of electrons. So relation between valence electron and valency. What is the relation between valence electron and valency? That is, the capacity of an atom of an element to form chemical bonds is known as its valency. Keep in mind, students, capacity of an atom of an element to form chemical bonds is known as its valency. So, in a chemical reaction, valence electrons of an atom are either transferred to the valence electrons of another atom or shared with the valence electrons of another atom. So the valence electrons of an atom play significant role in chemical reaction. That is very important. Okay. Valence electrons of an atom play significant role in chemical reactions that result in the formation of compounds. So in a chemical reaction, atoms donate, share or accept electrons in order to complete their octet and achieve stability, that is octet fluid. Okay. So octet means what? It is an 8 valence electron. It is associated with the stability of the noble gases. Okay. Okay. So see, what is meant by the duet rule? If you take non-metals like hydrogen, oxygen, nitrogen, carbon, these are having the duet rule. In case of hydrogen, it can accommodate only 2 electrons in the valence shell to complete its doublet. Okay, duet rule. Like the oxygen also valence equal to 2, nitrogen valence equal to 3, carbon valence equal to 4. So thus we can also define the valency of an element as the number of electrons donated or accepted or shared by the atom of an element to complete its octet of electrons and achieve stability. Okay. So calculation of valency, first point. Atoms of metals tend to donate or lose electrons in order to achieve the stable noble gas configuration. Okay. If noble gases are stable means it can be donate or lose electrons in order to, okay, in order to achieve the stable noble gas configuration. Okay. So if atoms want to be stable, stable is equal to noble gas configuration. That means it's having 8 valence electrons. Okay. And then this is very important point, students. Keep in mind, valency of metal atoms is equal to number of valence electron in its atom. Okay, valency of metal is equal to number of valence electron in its atom. And then atoms of non-metals. Non-metals means like carbon, nitrogen, oxygen, fluorine, and then okay, these are the non-metals. Tend to accept or gain electron to achieve the stable configuration of the nearest noble gas. Okay. Non-metals also like that accept or gain electron to achieve the stable configuration like noble gas. So valency of non-metal is equal to that we have to do 8 minus number of valence electron in its atom. Okay. For example, nitrogen atomic number 7. The number of valence electron 5 means 8 minus 5. Okay, only the balance of non-metal you do like that. So 8 minus 5 we get 3. So the nitrogen balance is 3. Okay. So we have to discuss here. See, nitrogen atomic number 7. It is the non-metals. That means the electron combination 2, 5. This 5 is a number of valence electron. That means 8 minus 5 we get 3 electrons. So this is the 3 is a valence electron. So it is, and then valency for noble gases is 0. It is due to the fact that they already have the complete octet and are chemically stable. Okay. It is due to the fact that they already have a completed octet and are chemically stable. So in case of helium, although it has two valence electrons, okay, in case of helium, it has only two valence electrons. It is also a noble gas. Okay. So see this example: hydrogen, helium, lithium, gallium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. This is first we take first 20 elements balance. See, I tell no for that hydrogen balance is 1. Okay, because the atomic number 1, so in case the balance is also 1. Helium is a noble gas. I already told the balancing for noble gas is 0. So we say helium is 0, and then neon also 0, and then argon also 0. Okay, and then you see lithium 1. Okay, number of valence electron 1. Like that beryllium 2, boron 3, of the carbon, nitrogen, oxygen, fluorine is a non-metal. So that means 8 minus number of valence electron is atom. So we have to use this 4, 5, 6, 7 only. Here also see 4, 5, 6, 7. Okay, silicon, phosphorus, sulfur, chlorine. This also we have to use that formula. 8 minus 4 is equal to 4 because number of valence electron 4. Valence is also 4. And then because 8 minus 4, 4. Here 5. Number of valence electron 5, so 8 minus 5 is equal to 3. Okay, number of valence electron for oxygen 6. So valence we have to count in like 8 minus 6 is equal to 2. Okay. Studying the outermost electron shell of an atom is known as dash shell, valence shell. Okay, the outermost electron shell of an atom is known as valence shell. And the electrons present in the outermost shell of an atom are known as valence electrons. Okay, and electronic configuration of aluminum is 2, 8 and 3. The number of valence electron in it are dash. Option A 2, option B 8, option C 3. Aluminium, valence electron, you say 5 and 3. Okay, so 3 is the answer. So, and the atoms of metals tend to gas or lose electron in order to achieve the stable noble gas configuration, tend to donate or lose electrons in order to achieve the stable noble gas configuration. The valence of noble gases is 0. Okay. I hope all of you understood. Thank you so much. Thank you. Thank you so much.